To begin with, on a bright and sunny Saturday, we diligently try to calculate all of this with honest and straightforward lines. That is, we use the Befestnik to rise from the bottom up and read some optimal value. We were unable to derive the formula. The funny thing is that indeed the restrictions here are not actually entirely fair, perhaps somewhat actually. We have that the laughter with constraints from 1 to 10 in the 9th array cannot be more than, I don't remember the exact numbers in the analysis, approximately no more than exactly 4,000 in total. In short, that is, in other words, the mechanism here can be at most approximately 4,000 optimal. We no longer need to consider more. So, accordingly, we can now move towards the square, which will essentially be n by mech. And based on this detailed and comprehensive information, the DP will be meticulously constructed. How exactly will it be constructed? We will have DP and tejit, which will be carefully designed and implemented. For us, this will be considered, in essence, the sum of all of the mechanisms, essentially in totality. On the tree with the vertex I. Where is it? Where exactly? I wonder, where is it? Where? We are not considering one mech here, in which our current vertex is definitely involved, meaning that there might be some bamboo going on somewhere around here, something like that, and it will continue upwards somewhere. The price of this bamboo, that is essentially its mech, is G. This means we have calculated all the other mechs here in all the subtree. But we haven't actually finished this mech, this bamboo yet. Therefore, we are indeed not really adding this mech here yet. The data is entered into this specific cell, identified by its unique coordinates, ensuring precise data placement, and so this subtask is murky in certain aspects and places. Accordingly, how exactly will DP be precisely constructed in this context here? In the context of graph theory, if a vertex, which we can denote as vertex I, has no children or descendant vertices connected to it, then the length or depth of the graph at that particular vertex is essentially let's go, meaning there are no further nodes to traverse from vertex I. Starting from the initial state of 0, then for any dynamic programming state that is derived from the previously lived states, except for the specific state j, equal to the weight of the given vertex. That is, this flow cannot be for the given vertex. I think it is clear that for any of these things it will equal 0. Otherwise, in this particular situation, we will essentially have dp and gt equal to infinity. Since we simply cannot have such a flow, we will have the cost of such a trick as infinity. We cannot have the current unfinished flow equal to the value at this vertex, because it would lead to inconsistencies and errors in our calculations. Next, we can branch out to explore other possibilities and solutions. If we have one child.
Want to become a great programmer? Subscribe to our Telegram channel.
So what does that mean? Here we are choosing, and it is crucial to fully understand the implications of our choices. We write, I need to wash it. No, I'll redraw it. We have, for example, this kind of tree. This is how we can see the descent. And further along, we have more in the tree. This is our vertex I. This is this child node, which is a part of the larger data structure, also possesses its own unique value. Essentially, we are faced with the decision of whether to complete the flow that originates from a point somewhere below in the hierarchy. This particular flow is represented by the variable j, and our task is to complete it in this specific manner. Additionally, at this juncture, we will encounter the value associated with dp.childg. To elaborate further, the child node's value plays a crucial role in determining the overall outcome of the process. By carefully considering whether to finish the flow, we ensure that the data structure remains consistent and accurate. The variable j signifies a specific pathway within the structure and completing it correctly is essential for the integrity of the entire system. Furthermore, the value dp.childg is an integral part of this process, contributing to the final result in a significant way. Additionally, you can directly add the value of g to the equation without any intermediate steps. Or we continue to pull this bamboo up and move forward with determination and persistence as we strive to achieve our goals. In this case, we simply pass what we have read in the chiode, meaning we are not adding anything yet. We continue to pull. At this current stage, we want to add a vertex to the bamboo. We are considering whether we will add this vertex, or more precisely, how we will add this bamboo to the flow. We are thinking about whether we finish it at this vertex or continue. We start a new one and add to this one, which means we initiate a fresh instance and incorporate it into the existing one. Yes, we can have either this option or that one, and we continue by pulling in a new one. And accordingly, there will be the requisite formula where we explore all possible j, ensuring that every potential scenario is thoroughly examined and considered. And we look at the minimum and for they refer to the aj or dv, which are important elements in the context of the discussion. Additionally, they mention the plus factor and where j fits into the overall picture. This comprehensive explanation ensures clarity and understanding. The value or result that we are discussing here does not match or correspond to the one we are comparing it with in any way.
Want to become a great programmer? Subscribe to our Telegram channel.